Okay, so this lecture talks about neutralization. And neutralization is something that when you have an acid and a base put together, they are going to neutralize each other out. So if you remember when we talk about that pH scale and the acids fall down on the 0 to 6, and then up here you have 14. So the whole pH scale goes from 1 to 14. In the middle, you would have 7, and that's something that's neutral. So if you put something acidic and you add that to something that's basic, they're going to neutralize each other. So neutralization is the reaction of an acid with a base, and what's going to be produced is water and a salt, always. So an example would be sodium hydroxide. This would be our base with hydrochloric acid. That's our acid. So you would write that HCl, hydrochloric acid, plus sodium hydroxide. Make sure you check your charges. 1 to 1 and 1 to 1. And then this is going to be a double replacement. All neutralization reactions are a double replacement, which means that H and Na are going to swap places. And we just said up in the definition that you are always going to get water and a salt. And in this case, it's going to be sodium chloride after that double replacement. So down in the vocabulary after number 2, the neutralization is the reaction of an acid with a base, and you will produce, I don't know why it's doing this again, water and a salt. The salt is the substance consisting of the anion from an acid and the cation from the base. Remember, cations are found on the left side of your chem helper, and they are a positive ion. Anions are negative ions, and those are on the right side of the chem helper on that front page. Okay, so everything's going to be a double replacement. So that means that if you look up top again, H and sodium, they replace each other. They're going to swap places. In terms of a titration, it's the process of adding a known amount of a solution to a known constant to determine the concentration of the other one. So we are going to look at the equations that go with that. But if you were to do it, you might have what we call a burette. Okay, and it's this tube of glass with a point on it, and then there's like a stopcock on the side to add things drop by drop. And then down here, we'd be able to have a beaker, okay? And in this burette, we have a known concentration of, let's say, a base, okay? And then we are going to put our acid in here, and maybe we put phenolphthalein indicator. And that's the stuff that once it becomes basic, it would turn pink. Phenolphthalein, something like that. Indicator is in there. So inside this beaker, we have acid, and then we put some of this indicator in there as well. It's usually clear until we have enough basic stuff added. So at some point after this drop goes in there and you count it 1 by 1 by 1, something that is acidic inside of here is now going to turn over to basic because we've added so much of that base. So now in this beaker down here, we have more base than acid, and guess what? That phenolphthalein indicator is going to turn a bright pink.